Greetings, groovy geographers. So I went ahead and made a little demo video for use of the Analemma, which you will use as part of Lab 8, which is the Solar Relationships Lab. This is kind of a tricky diagram, so yeah, I'm going to go ahead and show you an example of how to walk through it, and hopefully that will help you on the lab. So this is the image that you'll have included on your Canvas page. Huge thank you to a former student who made this for me. It's kind of hard to find these that are open source, but she went through and spruced up for me. The original was all in German, and I don't speak German. Okay, so if you think about the declination of the sun, right? So the Earth is moving around the sun, and we're tilted. And what this means is that the sun's direct rays are focused on the Earth at different points on different times of the year. I like to think of the declination or the subsolar point as like the high five latitude. If you think about when you give a friend a really good high five, right? You have that good palm contact, right? It's lots of energy right there. So there's lots of energy, direct contact, and that's what's happening at the declination or the subsolar point, is the sun is giving direct, high-quality energy directly to the Earth. What the Analemma does is the Analemma allows you to calculate what the latitude of the sun's declination is based on the day of the year. You'll also look at tangential rays in your Lab 8, which I like to think of as like, you know, you go to give someone a high five and they go too slow and they miss, so you're like, you can five. So you kind of just barely graze each other. There's not like good contact or anything, right? It's not very satisfying. Like one of you misses, it's a very non-satisfying high five. That's what I think of as the tangential rays, which are the low quality rays that are kind of just skimming off the sides of the Earth and not bringing high quality, good sunlight. So what the Analemma does, if you were to set up a camera and take a picture of the sun in the sky at noon every day for a year, it would make this kind of shape, right? Except sideways, but you get the idea, right? So you can ignore the numbers here on the top. We're not going to worry about those. And you can ignore the numbers on the bottom. Don't worry about those. What we're going to look at is going to be the numbers on the side. And this stands for the latitude. So this point here is 0, right? So that's going to be our equator. And I used to have a little thing that I could draw. I think that I don't have it anymore. Darn. Oh, wait, here. Ha! I can draw now. Let's pick a fun color. Let's do like fuchsia. Ooh, let's do pink. I get too excited about this. Okay, so that's going to be your equator. Okay, now think about that chart that I had you look at on Lab 8, and you've probably gone over it in your lab. When in the year is the sun focused on the equator? Twice a year, right? On our equinoxes. Well, what do you know? My red line crosses the equator twice a year. And those are going to correspond to the equinoxes, right? This is where it gets a little messy. Is you have to guesstimate the dates based on these little red lengths of line. So for example, think about the fall equinox that we just had was September 21st, 22nd or something, right? So this blue dot right here is September 1st. And this blue dot right here is October 1st. So based on that, what do you think this dot right here is? What I like to do is I put a little slash through the middle. That's about halfway, so September 15th. So we know that it's between September 15th and October 1st, so you can estimate that as like September 20th, 21st, right? So there's a range of values that I'll accept. I don't expect you to get the exact dot, right? And you can do the same over here as well. So if this is March 1st, and this is April 1st, you're like, okay, well, it's kind of halfway through the middle. So if this is the 15th right about there, maybe it's like March 18th, 19th, right? So you're guesstimating the numbers. Okay, so when you have values that are in this section up here, that means that your declination of the sun is in the northern hemisphere. So the northern hemisphere is experiencing summer. So think about, right, July we here in the Northern Hemisphere are experiencing hot, right? And we really, between really starting in like May through September, we're experiencing warmth up here, right? The opposite happens down here. If you're down here, this is going to be the Southern Hemisphere. So you think about the sun will be focused in, the Southern Hemisphere. So we here in the Northern Hemisphere experience winter, right? So think about how cold it is here, really starting in October, if you're not in the Bay Area, all the way through, I've seen snow in Chicago in March. Okay, so that's going to be how these numbers here work. Okay, so let's go ahead and pick a random date. We'll do, I don't know, November 5th. Sure, why not? Remember the 5th of November. Okay, so here's November 1st, and here's December 1st. So I'm going to go ahead and guesstimate, where do I think November 5th is? So if this is the 15th, I don't know, maybe right there. What do you think? Sure, why not? Again, you're guesstimating. I'm not going to make you do an exact date. So if I guesstimate this is November 5th, let's go ahead and follow it to the side. The numbers on the right of your analemma are the same as the one on the left. Let's see here, negative 15. So negative means either south or west, and then positive means either north or east. So you can either say that your declination is negative 15 or 15 degrees south. They mean the same thing. Kind of depends on what system you're using. So let's see here, it's between 15 and 16, so what do you think? Let's say 15.5 degrees south. Sounds good, right? So that means that on November 5th, the subsolar point of the sun is at 15.5 degrees south. That's how this would work. Or maybe I'll give you a latitude and say, all right, on what day is my declination at 3 degrees south? Okay, so we'll find our 3 degrees south. Ooh, I have a highlighter function. Aha. They shouldn't give me so many toys. It's too much fun. Okay. Oh, it doesn't really hide up. Oh, okay. Never mind. Highlighter function doesn't work. That's sad. Okay, fine. Let's pick a new color. Let's pick yellow here. Okay. So here's my 3 degrees south. Let's go ahead and see it crosses the line. Okay, so there's 1 point. Keep going. And there's another point. Okay. Well, this one turned out nicely. We're going to go ahead and say that on October 1st, because it intersects that little blue dot, October 1st, the declination of the sun is at 3 degrees south. This one here, okay, so it's after March 1st, but it's before March 15th. So what do you think? Want to say like March 10th, March 11th? Sure, right? Again, there's a range I'll accept. So that's how this analemma works. As you can see, this one's day the 14th because our Earth is wobbling. It's called the precession. We don't have a very even rotation. So this does change every year. But again, I'm more interested in you practicing using this tool that geographers use out in the field. And I'm less concerned about you getting super duper exact numbers. It's more about the experience of seeing how you could predict where the sun will be based on time of year, based on how the Earth is revolving around the sun. Okay, I hope this is helpful. Email me if you have questions, and I'll see you later. Take care.